Hello everyone, welcome to our comprehensive ArcGIS Pro tutorial. In this video, we will explore the full capabilities of this powerful software, showing you how to create, edit, and analyze maps, from basic principles to advanced techniques. We'll cover everything you need to know to effectively use ArcGIS Pro in your projects. So join us on this educational journey and enjoy discovering the amazing features of ArcGIS Pro. ArcGIS Pro is an advanced software for geographic data analysis and mapping developed by Esri. It allows users to visualize and analyze spatial data in both 2D and 3D. With powerful features like spatial analysis, interactive map creation, and integration of diverse datasets, ArcGIS Pro is an essential tool for researchers, engineers, and urban planners. The software also offers online sharing capabilities and collaboration tools, make it easier to work together on projects. Before getting started, I want you to subscribe to my channel and like the video. Your support helps me create more useful videos. Now that we're familiar with ArcGIS Pro, let's dive into the real-world application of this software. The first step we want to take is to create a new project. Together, we will see how to design maps and add data to our projects. We'll also take a look at various tools and learn how to use them for spatial analysis. Are you ready? Let's get started. When you install the software, open it. If you haven't already, take a look at our channel. If you haven't created the shortcut on the desktop, using the search section you can find it. For example, here, both ArcGIS Pro and ArcGIS or ArcMap are displayed for us. We open the ArcGIS Pro. As soon as the ArcGIS is open, the home window appears. When we open ArcGIS Pro, a page called the Start page is displayed. That offers various options. This section allows us to start working on new projects by selecting an appropriate template. Templates usually include various options such as 2D and 3D maps, spatial analysis projects, and other predefined layouts. Additionally, on this page, we can open recent projects or create new ones. In the New Project section, a few specific parts are highlighted. Map section, which creates a project with your ArcGIS default base map. Catalog section, which creates a project for managing data and databases. Global Scene section, which creates a project with your ArcGIS default base map and a default elevation surface. Local Scene, like the Global Scene, uses your ArcGIS default base map and a default elevation surface to create a project. Also, an option has been provided that let us go ahead with that template. And in the Recent Projects section, all the previous projects have been listed and saved. By clicking on any of them, we can reopen that project. If needed, we can pin important projects at the top of this list. Or we can sort this list in various ways. If you notice, on the left side we have a few options: Home, Learning, and Settings. Home was here that contains projects, templates, and so on. The next one is Learning Resources. This section includes interactive tutorials, instructional videos, official documentation, and online resources. Additionally, webinars and online courses facilitate quicker and more in-depth learning. In this section, various types of training are available in form of videos or text. We can access more tutorials by clicking on More Tutorials. It redirects us to the ArcGIS Pro website, where we can study excellent and relevant tutorials for each section of the software. The link to the website has been provided in the description of this video. For some topics, videos are also provided to offer better training on those subjects. So now to create a new project, we go back to the Home section and select one of the options based on our needs. Since we intend to create a map project, we click on the map and fill or change the required items in the Create a New Project window. For example, we assign a specific name to the project, or change the project save location and save the project in a specified directory. If you needed a new folder for the project, you can tick its box. Finally, we click on OK. ArcGIS Pro software is open and we can use it now. On the top of the page, the name of the project is displayed. This means that the project is currently in progress. All activities in the software are saved to this project. This software has several main sections and useful menus. The first section is the Catalog section. This section allows users to manage their geographic resources. Here you can access various data such as layers, maps, tables, databases, and analytical tools. Through the catalog, you can search for data, organize it, and easily access the information you need. The next section is the Contents section. This section displays the layers and elements presented on the map. You can change the order of the layers, activate or deactivate them, and apply various settings for displaying each layer. This way, managing and viewing data becomes much easier. The next section is the Map View section. This section is where your maps and geographic layers are visually displayed. You can zoom in on the map, pan and perform visual data analysis. Various tools for measuring, selecting, and editing data are available in this section. Ribbon section. The upper part of the software, known as the ribbon, includes various tools and options that help you perform different operations. This section is divided into several categories such as Home, Map, Analysis, View. This structure allows users to easily and quickly access the tools they need and perform their tasks. There are various models available for the Contents section, allowing us to display the layers by selecting any of them. In the Catalog section, we have maps, toolbars, databases, style, folders, and locators. And at the bottom of the page, we have the tools such as snapping, grid, constraints, inference, and corrections. The coordinate system is also located in the middle bottom of the page. We can change the location of all sections within the software. By clicking on each section, we can move it to another location within the software. This way, we can rearrange each section in a suitable location according to our preferences. In the Insert section of the ribbon in ArcGIS Pro, the New Map option allows users to create new maps. This option includes submenus that enable the creation of different types of maps with various settings, such as 2D and 3D scene or maps. This feature helps users to organize their projects more effectively and present their geographic analysis visually. Let's look at the submenus of the New Map option. The first one is the New Map. This option creates a blank 2D map to which you can add various layers and data. This map is designed for general analysis and displaying data in a 2D environment. The second one is Global Scene. This option is used to create a global 3D scene that allows users to view data globally in a 3-dimensional perspective. This type of map is especially suitable for global-scale geographic analysis and accurately modeling large environments. New Local Scene. This option is designed to create local 3D scenes, allowing users to analyze data on a smaller scale with greater detail. This type of map enables users to view data from different angles and examine more details in local environments. New Stereo Map. This option is for creating maps that allow users to use a stereo 3-dimensional view. This type of map is particularly useful in a specific application such as geology or environmental surveys, enabling users to see more depth and details in 3D data. New Base Map. This option allows users to add a new base map. Base maps typically include essential geographic information such as streets, borders, and regional weather, serving as a background for other layers. In the View section of the ribbon in ArcGIS Pro, we can display the Catalog view. One of the powerful features of this software is that it can handle 2D maps, 3D scenes, and the catalog simultaneously, eliminating the need to create separate software for displaying each one. Now let's look at the software settings. To do so, we go to the Project section and click on the Options. As you can see, it's been divided into two parts: project-related settings and application settings. In ArcGIS Pro, the project properties settings allow users to configure various features of the project. These settings include maps and layers, units of measurements, storage settings, project components. These settings help users optimize their workspace and manage projects more effectively. As you can see in the Current Settings section, we can see the name of the saved project, the saved path. As you can see in the Current Settings section, we can see the name of the saved project, the saved path, and the specified home folder path, which we can change, or the specified default geodatabase for which we can change the path, and finally the default toolbox. In the unit section, all units of measurement can be changed. Here we check all these units and make changes if necessary. Distance units, we set it to kilometers. Angular units, area units, we set it to square kilometers. Location units, direction units, page units, we set it to centimeters. 2D symbol display units, we set it to centimeters as well. 3D symbol display units. And finally, the task section, that we can enable or disable the task history. We can refer to this section for map settings. In the general section, we can make some map settings. Start ArcGIS Pro. How should the software start? With start page, without template, or with the default project. Here you can choose different models to start the software in the same way. Create projects. How should all files be saved? Default location or custom location? In this section, you can specify whether they should be saved by default or in a specific location. Map and Scene section. Base map. The base map can be displayed by default, or a specific base map can be selected to be displayed when the software is opened. If we set it to this option, we should choose a base map. Let's save the settings and create a map to see it loads our chosen base map. From the catalog section, we right-click on the map option and select the new map. Here, the new map will be displayed with the base map that we just selected. We can change it to another base map. You can choose different base maps according to your preference or your desire. We can enable the Add Layer option. Similarly, we can change the coordinate system. If you need a specific coordinate system, you can select it so that when creating a new map, it will be displayed based on that selected coordinate system. The default label engine can be selected in two ways, Maplex or Standard. The ground elevation surface can also be specified, which can be set as default or selected based on a specific elevation source. Or you can select the No Elevation Source option. And finally, you can turn on the Manage Feature Cache from the Map tab option. These are software settings in all sections. The settings of each section can be changed separately and work with the software according to your needs. The Data Connection section in ArcGIS Pro is a vital tool for managing and connecting with data. This section allows users to access various data sources such as databases, GIS files, web services, and online layers. Some of its features are database connectivity, local storage data, web services, resource management. This tool helps GIS analysts quickly and effectively access the data they need and advance their projects with greater precision. To create data connections from Catalog section, right-click on the folder. Then select the Add Folder Connection option. We navigate to the path where our folder is stored. Then select the desired folder. By clicking on OK, the folder is added to the folder section. And we'll have quick access to the content inside the folder in ArcGIS Pro. All files in different formats can be displayed here. We have Landsat 9 images, all bands can be displayed, and we can import it to the software. We have the photos in PNG format, and the point, line, and polygon shapefiles, CSV file, or DEM, which stands for Digital Elevation Model. If you right-click on the database, you'll access a few options. For example, you can create a new database connection, create a new database itself, mobile database, and so on. As mentioned, it supports a variety of platforms: SQL, Oracle, Snowflake, and so on. Okay guys, now let's continue with adding raster data to the software. In order to be able to import the raster data into the software, we go to the folder that we've just connected. Here we got Landsat 9 satellite image that already downloaded. If you're going to download the Landsat 9 images too, you can go to the Earth Explorer website to download Landsat images. We place the link of the website and the tutorial link for downloading Landsat images in the description. Okay, we open the Landsat 9 image folder. As you can see, all the bands are here, mostly in TIFF format. One of them is MTL file, which is in text format. But what exactly the MTL file is? This file is metadata. In order to display the Landsat 9 image in full bands, we can only import this file into the software instead of importing all bands one by one. As you can see, by importing it, the image of Landsat 9 was open. Now, by changing the base map, you can have a better understanding over your area and your image. The way we imported our raster layer was the easiest way, but there's another option that allows us to import raster layers. It's Add Data option. It's accessible in the Map tab. If you click on it, you'll see many options to add types of data. Each one of them has a specific application. Since we want to add raster data, we use the first option. Now just find and import your raster data. So there are two ways to add data into the software: Catalog section and Add Data option. Now let's find out how we can import a shapefile to ArcGIS Pro. For those who are new to these terms, the shapefile is a geospatial vector data format for geographic information system software. It is developed and regulated by Esri as a mostly open specification for data interoperability among Esri and other GIS software products. And it has three types: polygon, line, and point. Okay, to import the shapefile into this software, we go to the Catalog section and the Folder section again, and find the folder that we just connected, because there are shapefiles in this folder. The shapefiles are specified based on their types. For example, here the polygon can be displayed in the shape of a polygon. If we right-click on the shapefile and select Properties, its specifications are displayed. For example, what type of data it is, or where you can find the data on your computer, what's its geometry type, and other options such as shapefile extent, spatial references, and so on. As said, each shapefile has an icon showing what type of data it is. For example, line shapefile icons are shown with multiple lines on it. Or point shapefiles are displayed as multiple points on it. To add a shapefile, just right-click on it and select the Add to Current Map option. In this way, we can import and display all the shapefiles in the software. To show you, I import all types of shapefiles to the map. Each shapefile has an attribute table that includes columns and rows showing the shapefile information. Using the attribute table option, we can access the specifications of each shapefile. For example, what type of the shapefile it is, the name of the area that the shapefile covers, how much is its length and area. A few of these columns are already predefined by the creator of the shapefile, but there are other options that you can calculate and add to a shapefile as a column, which we will find out later on how to add a column to a shapefile. One of the things that needs to be taught is to add a text or CSV file to ArcGIS Pro. So to add such files, we go to the Map section and select the Add Data option. As already mentioned, here are the types of data add models that each one has a specific application. Since I'm going to add a text file or a CSV file, so I choose the XY point data option. But be aware and pay attention that only when you can add a CSV file that the file contains latitude and longitude. When you click on it, the geoprocessing is displayed on the right side. As you can see, there are a few items with a red star beside them that should be filled. The first one is the input table. For this item, we import our CSV file. As I already said, your CSV file should contain latitude and longitude. Here, it has automatically identified the latitude and longitude coordinates in X and Y field, as well as the output feature class. If you click on the little down arrow, you'll see other available information in your file. There is a Z field as well, which is optional. If you have the height information of your area in the CSV file, defining it in this field will give the height data that help you with 3D generation and better understanding over your area. Finally, run the command. As you can see, the earthquake map of the whole world was imported as point file. When you go to its attribute table, you'll see all the information in your CSV file. If you need to make an earthquake map or download the earthquake data for the whole world, you can refer to the video link in the description. Alright guys, one of the most useful data that can be used is DEM. If I tell you what a DEM is, to summarize, a digital elevation model or DEM is a generalized term for a raster dataset with a regular grid of elevation information. DEMs are popular for calculations, manipulations, and further analysis of an area, and analysis based on the elevation. Now let's see how to import the DEM to ArcGIS Pro. In order to add the digital elevation model to the software or to your projects, from the catalog section, find the DEM file. If you're new to DEM and don't know how to download the DEM, even with high resolution, we've previously created a video about it that you can refer to. When you find the DEM, just right-click on it and select Add to Current Map. As you see, it was added to our project. Now, if I click on each part, the value of that part will be shown. From the contents, our DEM has a color scheme showing the highest and lowest values in our DEM, which is in this case, our highest areas are shown as white color and lowest regions as black color. Now, if I double click on the color, a small window is open that let us change the colors. By selecting this little icon below the color bar, the color scheme will be inverted. I click on it once again, but this time I'm going to go to Color Scheme Editor. So click the little down arrow beside the color bar to expand it. Below the colors, there is an option written Format Color Scheme. If I click on it, the color scheme editor is opened. Now we can apply more changes on this layer. We can turn off a range of the DEM so that only the parts we want is displayed. With this method, we can filter so that the desired parts be displayed. We can change the color scheme based on our region and taste, and display by combining different colors. As you can see, only the areas with higher heights are displayed, and the rest of the parts become colorless and the base map is displayed. Though using the symbology you can make some changes, which we'll be reviewing in the continuing and get more familiar with the symbology section. But keep it in mind that using the symbology we can open the color scheme editor as well. Okay guys, as I said, DM is one of the most useful data that you can work with. One of the derivatives of DM is contour line. A line on a map joining points of equal height above or below sea level is called contour line. Contour lines are curved, straight, or a mixture of both lines describing valleys and hills, the steepness or gentleness of slopes. The distance or the interval between the lines shows the elevation difference. The closer the line, the higher the height, and vice versa. Okay, I hope I got it through to you. Now let's generate contour lines. In order to generate the contour line, obviously we need a DEM. After adding the DEM layer, which we've already done, we should go to the Imagery tab from the ribbon and select the Raster Functions tool. By selecting this tool, all raster functions will be displayed on the right side. We can either search for the desired function or find it among the other functions, which I prefer searching because it gets us through faster. When you open it, the Contour Properties section appears. Now we have to complete the requested items. In the Raster section, I define our DEM. Let the smoothing as default, and for the Contour tab, you can have the lines only. Fill the lines or make them as surface instead of the lines. Since the lines are more popular, so I set it to the line only. In the next step, we have Z-base option, which says from what height the line should be generated. In other words, is the starting height for the lines. In the next item, you can specify the number of contours. The more number equals to the more lines on the map. Also, the contour interval or lines distances can be specified, which I set it to 100. You can also define the nth contour line in bold. I set it to 10 so that the 10th contour lines are displayed in bold. And finally, click the Run. Once again, we can draw the contour lines by changing the parameters. This time, I set the contour interval to 200. Also set the nth contour line in bold to 5. And can change the color scheme for each output. As you can see, areas with extreme elevation changes have many contour lines, and areas with less elevation changes have less contour lines. Okay, it's time to import another handy data to ArcGIS Pro, which most of the time we deal with it. Let's see how we can create a shapefile and add it to our projects. To tell you what shapefile is, well, shapefiles are one of the most common file formats for geospatial data. They store data as points, lines, or polygons. These three feature types form the basis of geospatial vector data analysis. We'll get more familiar with it in the continuing. Okay, let's first create a shapefile and see how a shapefile is created. In the catalog section, create a new folder. I create a new folder in the data folder to put all the created shapefiles in it. So I right-click on the folder and select New. Then on the expanded menu, I click the folder and set a name for it. Then this time right-click on the created folder. Again, from New, click the shapefile. A window is opened called Georeferencing. Here we can determine the specification of our new shapefile. In the first item, the feature class location should be defined, which here our data folder was recognized by the software. In the next item, we should assign a name for our feature class or shapefile. Then we should choose the geometry type based on the shapefile. Since the name of the shapefile is hospital, so I aim to create a point shapefile. You can select other geometry types depending on your aim and data. For instance, if your data is supposed to be a region, you should set it to polygon. Now I have to set a coordinate system for my shapefile to determine where my shapefile belongs to. You can either use the current map coordinate, which is in the main window, or specially determine a coordinate system for your shapefile using the globe icon beside it. I want to set it to the UTM coordinate system. So for this purpose, I click on Projected Coordinate System. Then find UTM and choose WGS 1984. Now, based on your region, choose either Northern Hemisphere or Southern Hemisphere. And I choose the specific UTM of my region. Finally, click the Run. As you can see, the shapefile was created. Also, other shapefiles can be created in the same way. For example, this time I created Polygon. Also, the polyline is the same. This time, using the created files, the coordinate system of those shapefiles can be selected. So as you saw, in this way we can create the desired shapefiles in the ArcGIS Pro software. Okay, now let's see how to create a geodatabase in ArcGIS Pro. But first, you should learn what is a geodatabase, feature dataset, and feature class. Well, a geodatabase is a database designed to store and managing geographic data, allowing for efficient organization and analysis of spatial information. And a feature dataset is a collection of related feature classes used to organize similar geographic data together. Finally, a feature class is a structure that groups similar geographic features together. Each feature class contains objects such as points, lines, or polygons along with their descriptive attributes. Okay, to create a geodatabase, we go to the database folder and right-click on it, then select the New File Geodatabase option. Assign a name for the geodatabase and save it somewhere on your computer. Our geodatabase has been created here. You can see its properties if you want it. By right-clicking on the geodatabase, you can create a feature dataset or a feature class. I create several feature classes here. So I right-click and from New, select the feature class. In the name section, we set a name as usual. An alias name is also available. It's up to you whether to set it or not. For the next step, you should determine the feature type. So from the feature class type, I specify the feature type. I choose point here. You can also specify the geometric properties for your feature class, whether include m-value and z-value or not. You should know which one is needed for your feature class. I'll click on the next button. In the field section, you should add any fields that are needed. For example, I add a field called name with the data type text. And add a field called fClass with the data type of text. A field called code with the data type of long integer. And any other fields that you can enter based on the feature classes you have. Then go to the next step. Here we should choose the appropriate coordinate system that we'll need. I set it to UTM coordinate system. To do so, I go to the project coordinate system section. Select UTM and choose WGS 1984, Northern Hemisphere, Zone 39. Then I hit the next. Here you should specify the tolerance value. You can read its explanation to see what exactly it wants you to determine. And also storage configuration, which offers two different models that you can choose between them. And finally, I click on Finish to create our feature class. Now, if I go to the properties of the feature class, all this information is visible. Some fields may be 0 or undefined, which is natural because it's crude and needs adding more data. Let's create another feature class called Rivers. I choose this type as line because rivers are line features. Enter the required fields. And put other settings as default and click on the Finish option. And also let's create a feature class of polygon type. Write the name of the feature class, determine the fields of the feature class, and finally click on Finish. So on the whole, we created a geodatabase with 3 feature types of polygon, line, and point types. You can create different feature classes in the same way. Now let's edit the shapefiles in ArcGIS Pro. But what do I mean by editing shapefiles? Well, editing geographic data is the process of creating, modifying, or deleting features and related data on layers in a map. Each layer is connected to a data source that defines and stores the features. This is typically a geodatabase feature class or a feature service. With that being said, let's start editing our layers. In order to edit the existing shapefile, you need to import several shapefiles into the software. I try to add all kinds of shapefiles to show you editing each one in detail. Okay, now we have point, line, and polygon shapefiles. Let's start with the point shapefile. As you can see here, we have traffic points that are going to be edited. So to edit these points, from the ribbon go to the Edit tab. While the point shapefile has been selected, from the Feature section click Modify. The Modify feature window is open on the right side. Now you have access to lots of tools. By enabling each one, you can edit and modify your layers the way you want. For example, if I want to move the existing points from one place to another, I use the Move option. While the Move option has been enabled, I click on each point to be selected, and turns yellow, which means that the point was selected. Now if I move the cursor on the selected point, it turns to 4-direction mode, which means you can move it. All I have to do is just move the point to my desired location. When I'm satisfied and done, I click the green tick in the available toolbar to confirm my edit. Doing the same way, you can move other points. And imagine by any chance you've missed a point or need to create a new point. In this situation, just click the Create option in the ribbon beside the Modify. Pay attention that your point layer should be active, which in this case is traffic, because we want to create a new point in that shapefile. The Create Features window is displayed and our point shapefile is visible. Using this window, we can create a new feature class. So I click on the traffic, then using the available tools below it, I click the first option, which is point. After selection, now I'm able to click anywhere to create as many points as I want. Now if I activate another layer, doesn't matter what kind of shapefile it is, line, polygon, point, it's shown in the Create Feature window and allows you to create features for it. And by selecting the Modify option, you can edit the highlighted layer. Any editing you need can be done easily in this section. For example, I edit vertices here. Or reshape the layer. Or as I said, create a new line like the previous layer. And finally, let's do some changes on polygon layers. As you can see, the editing tools are available for Polygon too. Or create a new polygon. Or edit the polygons. A variety of polygon models can be drawn. All the things and editing tools that can be applied are also in this section in the ribbon. When you're done, it's time to save your editing. So in the ribbon, click on Save. Make sure that you save the editing, otherwise they will not be saved and you have to do them once again. And if you don't like the editing or don't want to save, just click the discard option. Okay guys, our next topic is snapping in ArcGIS Pro. For those who don't know what is snapping, well, snapping in ArcGIS Pro refers to the process of precisely connecting special features like points, lines, shapes to one another. This feature enhances the accuracy and consistency of data editing, georeferencing, and measure tools. Snapping is particularly useful for creating precise maps. Let's see what I mean by snapping in practical example and enhance our accuracy using snapping. Here we have a shapefile. In a certain area of the region, I intend to create several polygons. So as we just learned in the editing part, we can easily use the create option. For example, I want to draw a polygon for this region, but divide it into two separate polygons. So I do it this way. By zooming in on the polygon, we can see the accuracy of digitizing. Now if I confirm the editing, as you can see, there will be some distances between the polygons and they're not sticking together. On the other hand, in some areas, two layers are overlapping. So to avoid such types of issues, we use snapping. Now let's solve the issue. I changed the Polygon Symbology to a hollow one to clearly see what's going on, and I also delete one of the polygons to draw a better one. Then the same as editing, from the Edit tab in the ribbon, I click the snapping option. First, I have to turn on snapping. And also activate all snapping options. Then from its settings, I increase the XY tolerance. A tolerance of 20 pixels indicate that snapping will be applied within a distance of less than 20 pixels. Here you can see that when we get closer or hover over a layer, all the snapping options we just activated are displayed. And we can identify the edges of the polygon through this method. And the same as I do, you can create a new polygon precisely without any issues. As you can see, the two polygons are exactly overlapping. Okay guys, in this section we will find out what labeling is and how you can display it on your maps. In general, labeling refers to the process of placing descriptive text for features in maps derived from one or more feature attributes. If you need to display the label of all layers or some of them, use this method. Let's first take a look at our attribute table and see what fields we have. In other words, our shapefile has what information. As you can see, we have names, lengths, areas, district numbers, and so on. Now I close the table, and while the shapefile or feature class selected, I refer to the ribbon. 3 sections will be displayed at the top of the software: feature layer, labeling, and data. So I click labeling, and the labeling section is displayed. As you can see, now we can access all the labeling settings. On the left side, there is the labeling option, which should be enabled. And if you need to turn off the labels, just click this option to disable it. As soon as I enable it, the labels are displayed on our shapefile. Next to enabling tools, we have a label class collection. So from this section, we can change the labels shown on the shapefile. For instance, the labels are shown based on district number. Let's change it to other fields available in the attribute table. Also, there are different formats for displaying labels. You can choose different formats based on the language. It can be displayed as bold or italic, or simultaneously bold and italic. The color of the label can also be changed. You can choose black color for better display, which of course is completely dependent on the background and the type of layer symbology. Labels can be made smaller or larger. Another important part of the label is label placement. Based on our layer, we can choose the label placement model. In this section, there are various symbols to display labels better and more differently. You can use any of these symbols based on your needs and desire. Another feature of ArcGIS Pro is having base map in different types, which is easily available to users, and by choosing each one, you can access a very valuable base map. But what is a base map anyway? Well, base maps serve as a reference map on which you overlay data from layers and visualize geographic information. An individual base map can be made of multiple features, raster, or web layers. Base maps are the foundation for your maps and provide context for your work. Let me show you how you can add a base map to your projects. It's pretty straightforward. Just go to the Map tab in the ribbon and click the Base Map option. As you can see, it supports most of the important base maps. You just need to select any one you need to apply. For example, I add world imagery. Or world street map. Even world street map at night. Colored pencil. One of the fascinating base maps is this base map. So as you saw, in the same way you can use all kinds of base maps when working with ArcGIS Pro. Sometimes you need to export a vector file. Exporting data allows you to copy data to other geodatabases and optionally change the format of the data. To export a feature class or a shapefile, first add it to your project and right-click on it. Then go to the Data section. You see two options here, Export Features and Export Table. Export Features converts the shapefile to a feature class, and Export Table converts the table to a new table or geodatabase table. Let's first export our feature. So I'll click Export Features. A window is opened which you should enter the desired specifications and git export. So in the input feature, I select the layer I want to export. And in the output feature class, I define a path to save the file. In the filter section, you can apply types of filters on your output layer. And you can make changes on the fields, for example, determine which fields to export. Since I want to export the whole file, so I don't change anything and click OK. As you can see, it was exported and I changed the symbology to understand or highlight the exported file. In the same way, you can export the attribute tables of any layer, which directs us to the Export Table option. So again, I right-click on my layer and go to Data. This time, instead of Export Features, I click Export Table. The same as features, I enter the requested information. And as I told, since I want the whole file or table, I don't change anything. If needed, you can apply filters and exceptions to export your desired fields alone. So I finally click OK. As you can see, the table was saved in the mentioned path and can be seen here. Okay guys, the topic of this section is symbology. Let's see what it is and how we can use it. Symbology in GIS refers to the process of defining how spatial data is visually represented using various shapes, colors, and symbols. This includes points to represent specific locations, lines for features like roads and rivers, and polygons for areas such as cities and agricultural land. The goal of symbology is to enhance understanding and analysis of geographic data visually, effectively conveying information to users. Here we have three types of shapefiles as point, line, and polygon, which we work on each separately. Let's start with point layer. Our point layer is transport station. As you can see, it's just a bunch of simple points that are meaningless. Now I go to the symbology section of the software. There are several methods to open the symbology section. Either double-click on the point symbol below the transport station, or right-click on your layer and select the symbology. The symbology section appears on the right side in the catalog pane. From the primary symbology section, you can choose the various types of models to display your points, such as graduated colors or graduated symbols to display your points. You can use each one you like. Below that, there is a symbol option. If you click on the point next to it, you'll access a variety of two-dimensional models for points that you can choose anyone. Try to choose a symbol that is more related to your points and project. For example, in this case, which my points are transport stations, I'd better use symbols that indicate stations or buses or something like that. Next to Gallery, there is Properties option that allow you to edit your selected symbol. Make changes and edit your symbol as you wish and save it. After making any changes, you have to click the Apply button to execute it. For example, I choose a better color combination for my layer. The outline color, outline width, size, and angle are all changeable. By going to the Layer section, you can access more things to change. For example, in the first item, there are some ways to display the layer: shape marker, picture marker, 3D model marker, procedural marker. If I set it to the shape marker, I have 3 ways to choose the symbol for my layer: Style, Font, and File. Let's click on Style. As you can see, there are various styles here that we can use to display the layer better. You can easily choose the desired symbol or search for it using the available search bar. Choose a proper color for your symbol. Or change the size of your symbol. Here, I make the symbol bigger to be seen better. Then I click on the font. There are various fonts that you can use if needed. By choosing each of the fonts, there are all kinds of characters that we can use if needed. If you click on the element itself, you can make a series of changes on your element too. Here you can choose and use all kinds of shapes to better display your symbols. And by selecting the file option, if you have a symbol, you can easily import it to the software as a file and use it. Now let's set it to the picture marker option. Here we can as well use the style option, but it offers 3D style here. Or from the file section, import all types of files in PNG, GIF, JPEG, and other formats to the software. The next option is 3D Model Maker. Here you can use the 3D models to display your layers better. The purpose of the symbology is to better represent the features. So by using all these tools and options, you can have a better display for your different layers. When you choose a 3D symbol, now you can change its orientation on every axis. Or make the size of the symbol bigger or smaller. From the File section, you can import your own 3D models. Also, there are a few forms here that you can apply to your 3D symbology. And finally, we have the procedural marker that is a little advanced and rely on rule packages which are created in ArcGIS City Engine, and it's not the discussion of this episode. So let's get to the line layers and work a bit with line symbols. The same as the point layer, either you double-click on the line symbol or right-click on the layer and select the symbology option, you'll see the symbology pane. Then click the line symbol in the symbology pane. Unlike the point layers, we have three sections: solid stroke, picture stroke, and gradient stroke. Okay, the first one, which is solid stroke, you can change the color of the symbol, or increase its width. There are different dash types that you can choose from. Feel free to change all these sections and items to both know what's going on and get better in symbology. Now let's go to the picture stroke. If you have pictures, you can import and use them as symbols, as simple as that. After importing your images, you can change its quality, size, effects, and so on. Since I don't have a proper image right now, I passed this section. And finally, the last one is the gradient stroke, which offers different color schemes as well as other items that I already talked about. My river layer is green, which is not an indication of a river, so I turn it to blue and make it thicker. Now it's time to change the symbology of the polygon layers. So I open the symbology pane for my polygon layer. I firstly change its color and apply it to save the changes. To distinguish the polygons better, you can set an outline color, which here I turn it black. Even by increasing the outline width, you can get a better result. When I go to the symbology layer section, you'll see two options. You can apply changes for both the outline and the interior of the polygon separately. Each has different methods of adding symbology. I change the outline color. In the structure section, you can add a new effect or layer for better display. Even I add a new symbol layer. If I get back to the structure section, I can add effects. You can use many effects based on the need. Here I select the Move effect. The important part of adding an effect is its settings. For example, how much is offset X and offset Y? I randomly write number 3 and apply. You can see a preview of the effect at the bottom before you apply it. As you can see, the effect was applied to all polygons. I turn off the outline to have a better view over the polygons. Also, I changed the base map. In order to select a field to display, you can use the following method. First, I go to the attribute table of the shapefile to see what fields we do have. Here we have different types of land use. The language of this shapefile is Persian. Here we have the residential area and the rest of the land uses. We're going to show only the residential areas. So I close the table and right-click on the layer and select the properties. Then go to the definition query section. Here you can write any formula that you need. So I create a new definition query and select the desired field. As I said, since I only wanted the residential areas, so I set it to land use. Let me show you again. As you can see, the land use field exists in the table, which I intend to separate residential areas from. Let's get back to our query. As I said, I set it to land use, which means land use is my main field and I want to make something out of it. Next to it is conditioning, which I set it to is equal to. There are many other commands here that may be a little complicated, so you'll learn them at advanced levels. And finally, in the last field, I set it to the residential area. On the whole, we ask the software to separate residential areas from the land use field inside our table, and click on OK at the end. If you didn't see anything like me, just right-click on the layer and select Zoom to Layer. I turn off the created effect. I delete the query, and here we have all the land uses. Now I'm going to display the roads layer as unique values from Symbology. If I go to the attribute table of the layer, we can find out which of the fields has types of roads. So in the field section, I select the desired field. As you can see, it classified all types of roads available in the attribute table. Now I can determine a specific color combination. Even manually, you can determine a specific color combination for each of the values. The same as me. So, if you have a layer and the values are different, you can display your own layer like this. Now, I intend to focus on one of the key sections of ArcGIS Pro, Layout. Layout allows you to design and prepare your maps professionally for optimal printing or sharing. For example, I've added a series of layers to my project like power lines, rivers, and so on. And I also added a base map. Let's say this is our final map that we intend to print or share with somebody. So you'll need to get a layout to turn it to a standard map. Okay, to do so, you need to refer to a ribbon. and select Insert tab, then click on New Layout. It shows different sizes. Either your desired size is available or you should create it on your own. By selecting each one, you can get the layout in that size. These are mostly standard sizes that you can choose among, unless you want a specific size. So, based on your needs or your project, you can choose the dimensions of your layout. An option is also available that allows you to import your template as a reference size. As I said, you can customize the dimensions and create your own size. For example, change orientations, page units, and page size. After the size settings, from the ribbon, click the map frame. In fact, we should determine the frame of our map. There are a few default items along with our map, so I select the map, which is the first option here. Then I draw a polygon with my cursor, which in fact I specify the frame of the map. You can leave a part of the layout empty to place the map elements in that part. You can draw it this way as well if you'd like to. Here I'll leave some space at the bottom. And as you can see, the map was placed inside our drawn box. Now you have to right-click on the layer or the map and click the Activate option. By clicking this option, the map frame is confirmed and activated. Also, our layers are displayed in the Content section. Now you can move the map or zoom in and out, and put it in the right place. Now we have two tabs, Map and Layout, which we can switch between them. After being through with the map position, on the left upper corner, click the layout to get back to the layout to continue designing the map. If by any chance you want to make some changes on the map, just right-click on the map again, click Activate, make your changes, then click the layout on the left upper corner. As simple as that. Now I want to add map elements. Let's begin with north arrow. So on the ribbon, I click north arrow and choose one of the north arrows. If you're going to present your map or share it, it's better to use simple one. Now all I have to do is just draw a small polygon wherever I intend to place the north arrow. This way, the north arrow is placed inside the polygon. Then using the anchor points and the cursor, you can make it smaller or bigger or move it. Let's go to the scale bar. Based on its unit, whether imperial or metric, choose one of them. Again, I have to draw a polygon. And the scale bar is placed in it. I move it to the center. Now let's add a legend to our project. So from ribbon, click Legend. Various types of legend models are available that you can choose one. And the same as other elements, draw a polygon. Then double-click on the legend to open the element pane. Using this pane, you can modify your legend and improve it. For example, change its name, visible or not. There are a series of properties that you can change if needed. For example, in this section, you can specify the color of the border of the legend. Or turn on the background for your legend. By raising the gap for X and Y, the background color expands. You can do the same for border as well. or even apply a shadow for the legend. I'm going to change the background color. In the text symbol section, you can modify text elements in your legend. For instance, change the font, text sizes, outline color, etc. You can do this operation for scale bar as well. Add border, background color, or shadow to the scale bar. Or even use a better font. All the items can be applied to the notes arrow as well. One interesting feature is adding a table to the map, which is rarely available in other software. Using the table frame option, you can add a table to the map. After drawing a polygon, the element pane opens that you can determine which table and field should be displayed on your map. In the contents section, all the fields are specified. If you don't need any of them, you can turn them off so that they are not displayed. Let's make some displacements to design our map better and move the table to a better place. Now back to the ribbon again. Using the dynamic text, we can import all kinds of text models. Likewise, by using the picture option, we can easily import a picture and show it on the map. For example, I import the ArcGIS Pro logo and move it to an empty area. And ultimately, let's say this is our output. If I go to the Share tab in the ribbon, I can export it. So I click the Export Layout option. There are a few formats that you can export your map to. For instance, I want my map as an image, so I select JPEG format. The export pane is open that includes a few options. For example, here you can change the file type to other image formats like PNG and so on. I choose JPEG. Then save the output in a specific path and assign a name for it. From the compression, set the quality to the highest or max level, and change the resolution if you'd like to. Finally, specify the color depth and click the export option. After a few seconds, the output is exported. Let's open the exported map. As you can see, this is our final map. But the point is, this output is without Basemap. What could be the reason? Why the output was exported without Basemap? Leave a comment if you have an answer. Let's export the map again, but I cut this part to see your comments. This time, the map along with Basemap was exported correctly. Again, let me know in the comments what happened the first time our map was exported without Basemap. Looking forward to your answers. Okay guys, in this section I want to deal with the calculations in the attribute table. First, I need a dataset. In this case, I'm working with a river layer that contains 499 items. And my goal is to find out which river is the longest. To do this, I'll use the attribute table. So I right-click on the layer and select attribute table. In this table, we'll focus on the type field, because it's the field that contains various values and we need to filter out only the rivers. So for this purpose, I use the Select by Attribute option, which is available in the Map tab on the ribbon. In the Select by Attribute window, enter the river as input. And in the selection type, set it to New Selection because other options auto-remove an object, but we haven't created any selection yet. And in expression, we set the condition. Since our aimed feature is in type field, so put the selected field on type and set the operator to is equal to. And in this section, select the river. In fact, it recognizes the features in the type field. Now if I apply it, all the rivers are selected. Alright, we've selected 239 rivers out of 499 items. Now we're ready to calculate their lengths. To calculate the length, I want to create a new field to store the length of each river. So I click on the Add option. In the field name section, let's name it length. And set an appropriate data type. And finally, click on the Save option. As you can see, the field was created. Now let's right-click on it and select the Calculate Geometry option. Our geometry field is length, and set the property to length as well. You can use different property based on your needs. I set the length unit to kilometers. And click OK. The lengths will be calculated for each river. With the lengths calculated, now we can sort the rivers to find the longest one. So right-click on the length field and select Sort Descending. And the river at the top of the list will be the longest one in our dataset. And there you have it. We've successfully calculated the longest river in our dataset using the attribute table in GIS. This method can be applied to any spatial data where you need to compare lengths, areas, or other geometric properties. Great guys! Now it's time to create graphs. In ArcGIS Pro, you can visualize and explore your data using charts representing the tabular data. Without further ado, let's create a graph out of our data. Okay, obviously we create a graph from the tabular data, so we have to import our data or layer, which I used the river layer used in the previous section. Now I open the attribute table of the layer. Let's say we want to separate all the rivers from this main layer so we can create a graph specifically for their lengths. What am I supposed to do? You're right, calculate geometry is needed. I deliberately used this example to repeat calculate geometry process again. So, as shown in the previous section, we click on the Select by Attribute option. Add the river layer in the input rows, and in the expression section, we can choose the field we want to filter by, which the first one will be the type field because it contains our desired data, and the operator will be is equal to. And in the last item, I choose river because I want the river extracted from the type field. And finally apply it. Here, all the rivers were selected. Great! Now that we've selected all the rivers, we can right-click on the layer and choose Export Features to save this selection as a new layer. I save the output in a specific path. A new river layer was created, and now I can remove the main layer. With our new rivers layer ready, we can now create a graph. Inside the attribute table, right-click on the field you want to analyze. Let's say length in this case, and select the Statistics option. Now in the Contents pane, you'll see a new chart section added. On the right side, we have Chart Properties, where we can customize the graph to our liking, and make settings related to the graph. For example, we can turn on normal distribution to see how the data is spread out. Also, we can increase or decrease the amount of bins, or change their color. In the Statistics section, there are a series of statistical information like mean, median, or standard deviation. You can toggle those on or off right here. Other statistical information are displayed here, which have been calculated by the software. Data label is also available, which labels the bins. You can also change the color of any component. The settings related to axes are available in the next tab that you can change in both X and Y axis. In the next tab, we have the Guide tab that allows us to add a legend to the graph. The next tab is Format tab. Don't like the default theme? You can change that here and give a better visual vibe to the graph. You can also change the font of all the parameters inside the graph. And apply a better color for graph background. We can make some changes on grid lines as well, which gives different line models like solid, dot, or dash, and so on. In the General section, the graph title is changeable, and toggle on or off the names of x-axis and y-axis and change it if you need it. In general, we can apply the required changes in all graph items. Once you're satisfied with your graph, you can export it as a table or graphic for reports or presentations. Here you can see the exported graph. Closing the graph does not actually delete it, because if you pay attention, we can still see it in the contents pane. So to delete the graph, just right-click on the layer and select the delete option, as simple as that. And there you have it, a fully customized graph created in ArcGIS Pro. Great! It's time to georeference the scan maps or aerial images. If I want to explain the georeferencing theoretically, I'd say georeferencing or georegistration is a type of coordinate transformation that binds a digital raster image or vector database that represents a geographic space to a spatial reference system, usually a scan map or aerial photograph, thus locating the digital data in the real world. That's where the georeferencing comes in. Let's do it in practice. Let me find a map and add it to the project first. Here we go. As you can see, the map doesn't have any coordinate system attached to it yet. Now, we'll roughly navigate to the area that map represents. You'll most likely know where your map belongs to and represent. It doesn't need to be accurate for sure. Even if you didn't know where your map belongs to, just simply go to the desired country and go to the Imagery tab from the ribbon and click the georeference. Make sure to click on the map before activating the georeference. Once it's active, you'll see a new ribbon with the georeferencing options. Next, we'll use the Fit to Display command to make sure the map aligns with the area we're working on. This helps us get a better view of where we need to place our control points. I zoom in on the corner of the map. Now it's time to add control points. So I use the Add Control Points tool to mark the four corners of the map. Let's start with the first corner. I left-click on the corner and then right-click. The target coordinates window is brought up. If the map coordinates are x and y, you can enter them in this section. Otherwise, click on Show Coordinates in DMS. But in our case, we're using degrees, minutes, and seconds. So I click on Show Coordinates in DMS and enter the longitude and latitude values. Once that's done, hit OK. I right-click on the map and select Zoom to Layer to see the map. I'll repeat this process for all four corners of the map. I'll record the coordinates. Once we're done, we'll have four coordinates that tie our map to the real world. Now that our map was georeferenced, we can compare it with a base map to see how well it aligns with the actual surface of the Earth. This is a great way to check the accuracy of your work. As you can see, the map completely fitted the area of interest or where it was belonged to. Once everything looks good, we can save our file or save as a new file. As you can see in the coordinate system section, it automatically recognized the file coordinate. After saving, we'll close the georeference tool. And that's it. Our map is now georeferenced and ready to use. Okay, our next topic is Euclidean distance. The GIS experts are familiar with this term very well. For those who don't know what it is, I have to say the Euclidean distance measures the distance between 2 points and is super useful for urban planning, healthcare analysis, site selection, and such. Here I'm going to calculate the Euclidean distance of medical centers within a city. This is a great way to understand how accessible these facilities are across different areas. For this purpose, I have the medical center's point layer and the city boundary. For this task, I'll be using the Analysis tool. So go ahead and click on Analysis tab in the toolbar or ribbon. And select Tools. The geoprocessing pane is open. I search for the Euclidean distance command. Just type it in the search bar and you'll see it pops up. Go ahead and click on it. Once the Euclidean distance tool is open, we need to select our input data. In this case, we're using a point layer that represents the medical centers in the city. So in the Import Raster or Feature Source Data section, select your point layer. Now let's head over to the Environment section. Here we can specify the final output range. First, specify the output coordinate system. I choose the Shapefile coordinate system. This ensures that our output aligns with the existing data. Next, I'll set the extent based on the region's boundary. And this is important because we want to make sure our calculations are limited to the city boundaries. We can also set a mask based on the region's boundary. This will help us focus only on the areas we're interested in. And don't forget to set the output cell size. This determines the resolution of your output map. You can adjust it depending on how detailed you want your results to be. Once everything is set, it's time to hit run. Let's see what we get. Alright, here is the output map. In terms of symbology, we can display the output in a combination of different colors to make it easier to interpret. In this case, I've chosen a color gradient where darker blue represents greater Euclidean distances and lighter colors represent shorter distances. So the darker the blue, the farther away a medical center is from a given point, and the lighter the color, the closer it is. This is super helpful for visualizing accessibility across the city. And that's it. You've just calculated the Euclidean distance of medical centers within a city using GIS. This kind of analysis can be a game changer for urban planning, healthcare accessibility studies, and more. Alright guys, in this section let's extract rivers from a DM or a digital elevation model. I've added a DM layer and a base map to the project. To begin, head over to the Analysis tab on the ribbon and select the Tool option. In the Geoprocessing section, go to the Toolboxes section. Now, under the Spatial Analysis, select Hydrology. Several steps need to be processed to extract the rivers. The first step is to use the Fill command. This tool helps remove small imperfections in the DEM by filling sinks. Think of it as smoothing out the terrain so we can get a clearer picture of the water flow. You can access complete and detailed descriptions of tools and commands by clicking on Help. Here's additional information for these commands. Alright, let's run the fill command. I input the DM here and hit run. Once it's done, you'll see the output, which is a smoother version of our DEM. The next command is flow direction. This tool calculates the direction of water flow from each cell to its downslope neighbor. It's a crucial step in understanding how water moves across the landscape. You can also see the additional information of this command. Notice that the input for this step is the output from the fill command. Everything is connected. So I enter the output of the fill command in this section. Well, here you can see the result of the processing with a new raster layer showing the flow direction. The next step is flow accumulation. This command creates a raster of accumulated flow into each cell. And here is the output of the flow accumulation. Once we have our flow accumulation raster, we can start visualizing it better. Click on the value of the final map to adjust the symbology. In the primary symbology section, select Classify. Here you can adjust the number of classes to better represent the data. There are a variety of methods here, and I choose one of them. Finally, I use the reclassify command to fine-tune our results. Either search it or select the reclass from the raster section, and click Reclassify. I enter the output of the flow accumulation step for this section. And adjust the symbology to better display the extracted rivers. This step really helps in making the river network stand out. In continuation of the topic of the previous section and outputs that we had, drainage basins can also be extracted for any region. So with the previous outputs, we can extract basins. What this process does is create a raster that delineates all the drainage basins in your area. So let's extract basins. For this purpose, I return to the toolboxes in the geoprocessing pane, and under hydrology, I select basins. As mentioned in previous section, the input of this step is the output of the flow direction step. So I add extracted flow direction as input and hit run. Here, a basin has been extracted that you can use according to the region. And using the symbology, you can give a different color combination to your output to look better. Fine, let's work a little with 3D World in ArcGIS Pro. With ArcGIS Pro, you can combine the advantages of 3D scenes and 2D maps by showing both views at the same time, making GIS information more understandable and helping reveal new insights in the process. This is why the global scene option has been added to this software. Firstly, in Catalog pane, find your data and right-click on it. And select the Add to New option. Then from its extended menu, select the global scene. Here, the surface of the Earth is displayed in 3 dimensions. If I zoom out, you'll see the entire globe in 3D. This is what we call global 3D visualization. With just your mouse scroll, you can move around, zoom in, and explore different parts of the Earth. It's super intuitive and fun to play around with. You can see mountains, oceans, and even cities in 3D. Well, with the 3D view, you can perform all kinds of processing and analysis. Whether you're a student, a researcher, or just someone who loves geography, this tool can help you visualize the Earth. Okay guys, if you pay attention in the previous section, beside global scene, there is a local scene which gives a 3D view as well. But the main question is, what is the difference between global scene and local scene? Well, I have to say local scenes are best used for displaying or analyzing data at local or city scale that have a fixed extent in which you work. Local scenes are helpful for urban planning and visualization, such as when viewing campus facilities or building developments. But in a global scene, you can display special content on a sphere based on world. A global scene is a good choice when you want to understand or provide context for phenomena that wrap around the spherical surface of the Earth, such as global weather measurements, world population, or shipping lines. I thought it was necessary to explain the differences between the global and local scenes because you may face it in other software, so you'd better know what's going on. To use local 3D, the same as global, right-click on your layer. And from the Add New option, click Local Scene. Now that your layer is in the local 3D scene, you can start exploring it in 3 dimensions. Use your mouse scroll to move around and navigate through the area. With just a few scrolls, you can move around your area and view it from different angles. This gives you a much better sense of how everything looks in 3D space. It's a great way to visualize your project and make adjustments as needed. Let's continue with 3D World. Sometimes you may need to display your layers in 3D and add height to your shapefiles. This is super useful for visualizing spatial data in a more dynamic way. So first, I need to create a new map. Then go to the ribbon and click on Insert tab. From there, select the New Map option. And on its expanded menu, select New Local Scene to set up your 3D environment. Then choose the desired layer from the dataset and import it. You can simply drag and drop it. Once added, open the Layer Attribute table. Here you will see all the attributes associated with your layer, including a height column if you have one. This height column is the key, because it allows us to assign elevation to our shapefile. Go back to the ribbon and click on the Feature Layer tab. In the Extrusion section, there is a Type option. In the Type section, you'll see different display models that you can choose from. Here I select Max Height and set the field to Height. And the unit is meter. Now you can use your mouse scroll to navigate around the 3D model. This gives you a much better perspective of your data. If you want to improve the visualization even further, you can change the symbology of the layer to make it easier to interpret. And that's it. We've successfully displayed our layers in 3D and added height to our shapefiles. This technique is incredibly useful for anyone working with spatial data. Okay, heat map. What do I mean by heat map? Well, a heat map is a symbology style that shows the relative distribution of point density using a continuous color ramp that implies temperature ranging from cool, few points, to hot, many points. On the whole, heat maps are a great way to visualize data density. Let's see what it looks like in practice. In order to apply the heat map, you need to have a point layer, which I imported here. Then right-click on the layer and click the Symbology option. Now, in the Primary Symbology section, you'll see different display models. We're going to choose heat maps from the list. Just clicking on it and the heat map option will be activated. You can adjust the radius to change how the heat map looks. If you increase the radius, the heat map will spread out more, and if you decrease it, it will be more concentrated. Let's try setting it to 10 first, and then to 50. See how the heat map changes. You can play around with the radius until you get the look you want. You can customize the color scheme. Just click on the color option and choose whatever color you like. This is great for matching your heat map to your project's theme or making it more visually appealing. Finally, if you want to save your heat map as a raster file, you can use the Convert to Static Raster option. This will give you a raster output of your heat map, which you can use in other projects or share with your team. In most projects, you may need summary statistics to use their information. Summary statistics, along with the individual records in the report, combine to show the complete set of information for layer or table on which you are reporting. For example, you can compute the sum, average, count, standard deviation, minimum, and maximum value of any numeric field. To extract summary statistics from a layer, we do like this. If I go to the attribute table of the layer, the summary statistics could be extracted from the length field because it's the field which is numeric and could be used for the statistics. So I refer to the ribbon and go to the Analysis tab. Then from the Tools section, I look for Summary Statistics. In the Input section, I add my layer. Let's say we want to extract statistics from the length field. You can select all the fields you're interested in and choose the type of statistics you want to calculate, like mean, sum, or count. Once everything is set up, just hit the Run to generate the statistics. And there you go. The summary statistics are generated, and you can see all the calculated values right here. This is a great way to get a quick overview of your data. Now, there's another way to do this if you prefer working directly from the attribute table. Just open the attribute table of your layer, right-click on the field you want to analyze, and select the Summarize option. Like the previous method, here we select the desired fields and specify the statistical type of each field. The software will calculate the summary statistics for all the rows in your layer. Whether you use the ribbon analysis tool or the attribute table, both methods are quick and easy. Great! Layer package. A layer package is a file that contains both the layer properties and the dataset referenced by the layer. With a layer package, you can save and share everything about the layer, its symbology, labeling, field properties, and associated data. You can include multiple layers in a layer package. For example, we can save the layers with a special symbology, and if we import it, it will be imported with the same symbology. Okay, to do so, first right-click on the layer you want to save. From the menu, go to Sharing and select the Share as Layer Package option. There is a Save as Layer File option as well. A layer package is larger in size than a layer file because it includes the data. Others do not need to worry about access to your same data sources, so I click on the Layer Package option. Now you'll see two options for packaging. I'm going to choose Save Packages to File. This will let us save the layer package to a specific location on our computer. You can also add a summary and some tags to make it easier to identify later. This is especially helpful if you're sharing the package with others. In the Options section, you can customize how the package is saved. Once you've set everything up, click on the Analyze button to check for any issues. If everything looks good and there is no issues, go ahead and click the Package button. This will save your layer as a package with all the symbology and settings you've applied. The layer has been saved as a package correctly. Now, whenever you or someone else opens this package in the software, the layer will appear with the same symbology and settings you originally applied. In addition to layer packaging, there's another packaging which is called project packaging. A project package is a file that contains all maps and data referenced by its layers, as well as folder connections, toolboxes, georeferencing history, and attachments. Let's see how we can save our projects as package. For this purpose, firstly I go to the Share tab in the ribbon. Select the Project option. This will allow you to save your entire project as a package. Just like when saving a layer package, you'll have two options for packaging. We're going to choose Save Package to File, so we can save the project package to a specific location on our computer. Add a summary and some tags if you want. There are a number of options that we can choose from. Once you've set everything up, click on the Analyze button to check for any issues. If everything looks good and there are no errors, go ahead and click Package button. And done. Your project has been saved as a package. Now I'm going to reopen the software to show you how the package has been saved. Okay, now I import the saved package into the software. As you can see, the entire project will be restored exactly as you saved it. That's it, guys. I hope this tutorial was helpful. If you have any questions, drop them in the comments below. Don't forget to like and subscribe for more GIS tips and tutorials. Thanks for watching, and I'll see you in the next video.